Hey everyone, welcome back to another video. In this one we're going to discuss the minor updates to the Root controller and go through and upgrade my large Root 4 CNC machine to the Root controller and show off how shameful it's been for the past couple of years. I'm a little bit embarrassed, but I'll show you what I was running and what we're going to go to next. Right, first things first, let's discuss the Root controller and the upgrades it's got. So first and foremost, we've got an external antenna now. So this is going to be perfect for mounting it inside a metal enclosure. Here you could extend this with an SMA extension lead and have a remote mounted wireless antenna. This is perfect for the Wi-Fi and Bluetooth. So you can control it via a web terminal or via Bluetooth if you so wish. That's a nice little upgrade, so it gives you a bit more flexibility on how you mount it, or getting good Wi-Fi signal. I know here in the garage I don't get particularly good Wi-Fi, so being able to mount this remotely is perfect for me. Secondly, the Root controller 2.0 didn't have a selectable reference for the stepper output ports. Now we have, so the stepper motor drivers that I'm using has a common cathode on the OPTO isolated inputs for the stepper motor driver, whereas this can be selected between 0 volts and 5 volts depending on what the reference is on the given stepper motor driver you're using. So that just gives it a bit more flexibility in what this controller can interface with, and to do that there is some little jumpers. There we go, little jumpers down there that you just move up and down. If you wanted to, you could have the bottom row reference to 5 volt and the top row reference to 0 volt. So you could have a mix and match of drivers, but just note that it's in a pair of 3. And you can kind of see the denotation here, the rest set, and a little key here on what it is. So at the moment mine is a common cathode, so I'm going to set mine to both on the bottom. So you can see they're both on the bottom. So yeah, they're the standard motors that are in the bill of material. They're stepper motor drivers that are in the bill of materials. So yeah, if you're planning on using them, put the reference to 0. Right, that's the updates to the minor updates to the Root controller. Now this is what I've been running for a number of years on this machine. I've been doing all the development of the Root controller on the Root 4 Lite that you've seen in the previous videos, but I'm shamefully embarrassed to say that that's what my Root 4 has been running off. It was only supposed to be a temporary thing, so it's sat there for well over a year now, and I've just connected the wires in, and it's meant that I've not been able to shut the door in the cabinet at all. So this is the cabinet, and as you can see I've had these wires dangling down going into the cabinet for a period of time now, and that's all going to change now. I'm going to rip all of this out, get the Root controller mounted in there. I need to replace a fan on the power supply. It's a bit noisy now, and especially when it's cold it makes a horrible grinding sound until it gets up to speed. So out with the ramps, in with the Root controller, and I'll do some wiring management and get it connected up and drive the VFD via RS485 that I am so desperately missing. It works so good on the Root 4 Lite. I want it on this machine just so I can start and stop the spindle whenever, or via G-code. So I think for now I've got to rip out all these cables here, get rid of the old. I think I need to relabel it. I'll probably repurpose the cables, just trim them down and recrimp them, and then yeah, and I'm thinking I might mount, if I get the Root controller, I think I might mount it somewhere around about there-ish. There's not enough room up at the top, or on the door maybe. I suppose I could mount it onto the door. But yeah, in essence I'm thinking I'll mount it in there. That should give me enough room. Yeah, alright, well I think that's going to be it. I'll give a quick overview of the cabinet a little bit later once it's done. But yep, that's it. Hopefully by the end of today I should have the updated Root controller mounted in here, and I should be off and running. Right, so now I've got this wired up, I'll just give a quick overview of what we've got in this cabinet, just so you can get an appreciation of how simple this is. So first things first, power comes in to this double pole single throw switch. From here, this takes a feed that powers the VFD and then these two power supplies. So everything comes on in one go if I untwist this. And I've got a cooling fan as well that hasn't worked. Well, it doesn't do anything unless the door's shut, right? So hopefully that will actually do something going forwards. The two power supplies, one's a 24 volt and one is a 36 volt. This 36 volt is the one that powers the stepper motor drivers. This comes as a kit, so you can buy the stepper motor drivers and the power supply all together. And then this is just a standard 12 volt power supply. This doesn't have to be as powerful as the one I've got in here, it's just what I'd left over from a 3D printer project. But in essence, the 36 volt power supply just powers the stepper motor drivers. This 12 volt one powers the root controller and some LEDs that are plugged into my MOSFET outputs. And then that's kind of it. In the end, I didn't end up replacing the fan on this. I didn't have the correct size, because as you can tell, it's another day. Wiring wise, all the power of this are in parallel, so you can kind of see they have their own individual feed from the power supply, and then the output for each motor going out to each stepper. This is a braided cable, and the braid itself is connected to the chassis, and that is then connected to earth just to provide a bit of noise immunity. And then at the top half of this, we've got our discrete control. These are OPTO isolated. That the root controller is perfectly suited to drive LED based or OPTO isolated stepper motors. So with these 6 outputs here, are perfectly designed to drive the high current demands of the input stages of this. I'm actually somewhat surprised that this has managed to last as long as it did in its current form. As you can see, a couple of spiders have moved in. Sorry to them. Wiring wise, each stepper motor drivers driven independently from the root controller. So you can see I've got 4. Can you see 1, 2, 3, 4 outputs driving them independently, and FluidNC that runs on this controller will do the auto racking for us. So that's why I've populated on this side. You might be able to see. We'll go back, try and get rid of the shadow. I'm not really good at this. I've used the Y limit input as well as the B, because I'm using the B output over here for the second Y-axis motor. So they have just max end stops on that. The other ones you might have noticed that I doubled up the wiring. That's because the min and max end stops go for each limit. So these are just limit switches for each individual axis. So you could either have a min limit switch or a max, or a combination of both. I would definitely, if you're planning on running both, I've got these two, the min and max wires in parallel with one another. So you need to use normally open switches. If you don't know what that is, check out the video description for a link to the wiki. There's some graphical representations of the two different styles, series and parallel, normally open and normally closed switches. So in essence, that's kind of as simple as it can be. You saw me finally wire up this plug at the back here. That is to get the RS485 comms to the VFD. The VFD powers that little island, that isolated island on the root controller. So you can kind of see by the label denotation that the VFD powers that little part of the circuit just to keep the isolation zone powered. I've got nothing on the relays just yet. I might have a tool changer at some part in the future, we'll see, but hopefully I might be able to repurpose them. And the only thing that I've got on the MOSFET is my LED strip that you see on the bottom of my X-axis, and I will eventually put my mist line to it. I've got a little solenoid mounted that I can plug my air line up to, and I will use that to power the solenoid, but I haven't got there just yet. What else we got? We've got the power coming out the bottom of the VFD. I don't know if you can kind of see the 4 cables here for the 3-phase VFD, one being earth just as protection, and then here is your RS485 wires, and then this is 24 volts that the VFD provides. So, one thing to note that I haven't done yet, two things to note I haven't actually done. I've got a little panel mount USB port that I need to wire. I need to cut a cable up and wire to the back of this, because I've got actually on the front of here a little hole for it to go into, and then that's just if I wanted to mount the USB port. I probably will just for the commissioning phase of things, but going forward I don't intend to use this. I plan to just connect it to the Wi-Fi. On the topic of Wi-Fi, you'll note that the antenna's in here. I'm waiting to take delivery for a little SMA extension lead to take this up and panel mount it again on the outside. That hasn't arrived yet, so I'm just going to probably leave the door open whilst I test with the Wi-Fi, because the garage doesn't have the best Wi-Fi reception. So we'll just see how that goes. I might end up putting a panel mount SMA cable and then an extension lead kind of running up somewhere high or outside or whatever to get a bit of better reception to the house. One thing to note, the outer part of the SMA is connected to 0 volts of the internal reference of the controller. So what that means is if you connect the hang on, give me 1 second if I undo this. The outer part of this SMA cable is effectively 0 volt potential of the controller. You don't want to connect that to chassis, and because we've got a metal case here, we want to, I think I might do a 3D printed plug so I can mount it to the side of the case but not connect the chassis to 0 volts, because that could be it just ruins the isolation zone that goes on with the root controller, and considering it's fully isolated, you don't want to have a little mishap of connecting that to chassis or earth by virtue of connecting it to the chassis, to the metal enclosure. So I might end up making a little 3D printed plug to take the SMA panel mount, and we'll go from there. We'll see. I'll do another update to that video, or if I get it done, if the parts arrive in time, I'll get it done for this video. Right, so hopefully that in its current form will shut. Can't blimey, that this hasn't been shut since I brought the metal box. So yeah, it is looking sweet. Perfecto. So it's been a couple of days, or actually a fair few weeks, and the enclosure's done. The software has been updated to support the V20 from Siemens VFD drive. I've now got the external antenna wired in to a neat little plug, 3D printed plug that, like I mentioned earlier in the video, means I don't connect 0 volts to chassis, which is in turn is connected to ground on the mains cable, so the isolation zone is achieved. And I've also wired in the I'm casting a shadow here. I've also wired in the USB to the panel mount USB port that you can see there. So I think that's all of it. I've also, oh no, there's one more thing. There'll be a video coming out shortly showing you how I wired up the button and probe point for the CNC. So if I turn it on now, you can see it lights up with some software defined buttons. So at the moment I've got macro, start, hold, and they're LED lit, so I can press them and tell the machine to do what I want. Like I say, software defined, so there can be any combination you want. Links for the files for that and the wiring in the video description below. So that's a quick overview of the actual setup, the CNC setup. You probably appreciate it's not, it looks daunting, but it really is quite simple once you get your head around it. If you want to purchase the root controller, see the links in the description below, and check out the wiki if you need some more information on how to wire it up, or any other information about the Root CNC builds, or more specifically about wiring and software configuration of the root controller. It's forever growing, so if there's no information on there at the moment, please check back later, or better yet, ping me a message or contribute yourself. Either of them are great. So I hope you liked it, I hope you enjoyed the video. Please like, comment share, subscribe. There's a lot of stuff happening on the Root CNC development side of things, so stay tuned, and I'll catch you in the next one. Thanks, bye.